So let's say you're still struggling with exponential growth and decay functions. You should definitely jot this down right here. Y equals a times the base to whatever power x plus k. Now in algebra 2, we will have x minus h, but it's algebra 1. We don't have an h value. It's just a plus k at the very end, being added or subtracted at the very end. And we need to understand several things, like the a value ultimately tells you if it gets reflected over the x-axis. It tells you more, but we'll cover that in algebra 2. The base, that's very important, probably the most important one on tomorrow's test. The base, if the base is greater than 1, doesn't matter if it's a fraction or a decimal, if it's greater than 1, then it will be growth. And that makes total sense because any value, when you multiply any number times a value that's greater than 1, it will grow. Now, if this is a fraction or decimal that's between 0 and 1, then that's going to cause it to decay, to shrink, okay? So the base, if it's greater than 1, it grows. If it's between 0 and 1, it shrinks. If it's less than 1, it shrinks. The k value tells you your asymptote. But you know what? Let's get some good notes down right here. When you visually look at a graph, exponential growth functions from left to right grow away from the asymptote, which is the horizontal line y equals k. And of course, whatever that number is, that is your asymptote. So if you have a plus 3, your asymptote crosses the y-axis horizontally at 3. If this is a minus 2, your asymptote is at y equals negative 2, crosses the y-axis horizontally at y equals negative 2. So remember, your graph, whether it's a growth or decay, will infinitely approach that asymptote. Never actually touch, but infinitely approach. So how could we look at a graph and determine whether it's growth or decay? Well, an exponential growth function from left to right, we look at graphs the way we read sentences from left to right. And it will grow away from the asymptote, whatever that asymptote may be. So let me just do a quick example here, a quick sketch. Here's a quick sketch of an xy plane. Let's say my asymptote is at y equals negative 1. So it crosses the y-axis at negative 1. I usually draw it as a green dotted line. And let's say it's a growth function. That means that from left to right, it will grow away from the asymptote. So from left to right, it'll grow away from the asymptote. Now, of course, that makes a little more sense when we only put one arrow on it, but we know that there's also an arrow going to the left. And going to the left, it infinitely approaches the asymptote, but it never actually gets to it, never actually touches it. So that's an example of a visual of an exponential growth function. And it doesn't matter where your asymptote is at, it will grow from left to right, from the asymptote, grow away from the asymptote. That's what I meant to say. How about an exponential decay? Well, an exponential decay function from left to right decays towards the asymptote y equals k. So it doesn't matter where your asymptote is at. I mean, on the first example, I gave the asymptote at y equals negative 1. Maybe I should have drawn that up there. Y equals negative 1. That's the asymptote on that first one. Maybe, let's say that this one, the asymptote is the x-axis itself. So I'd put my asymptote right there. That'd technically be y equals 0. Okay. And a decay function from left to right decays towards the asymptote. So from left to right, you have like a huge value up here somewhere, and then all of a sudden it decays towards that asymptote forever. So that's a decay function. From left to right, kind of like reading a sentence, it gets closer and closer and closer and closer and closer and closer to the asymptote. It decays towards the asymptote. So we remember that there's several questions on the quiz. I just show you a graph and I say which ones are growths, which ones are decays. So you got to look at it from left to right, okay? And if it's growing away from the asymptote, then it's a growth function. If from left to right it grows towards the asymptote, it decays towards the asymptote, then it's a decay function. So let me go back to growth. Let me move this out of the way for a little while. That's a growth function. And let me try to incorporate the variables up here. If your asymptote is -1, that means that it should have a -1 at the very end over here. Okay, a -1. Okay, what else? The base. If this is growing from left to right, then this has to be a value that is greater than 1. Okay, maybe like the value 2. Okay, so what would be acceptable to see here? This function right here, maybe y equals 2 to the x minus 1. I mean, this right here may very well be that graph that I sketched right there. Obviously, it's not perfect, but it's very close to it. If you go to Desmos and type that in, you're going to get something that looks like that. Okay. Now, the question is, what would happen if, you see how like the a value out here, there is no number out here. So what would happen if I put a negative sign right there? What would happen? What would happen is it would reflect over the x-axis, right? Or in this case, over the asymptote. So if I did put a negative sign right here, and actually let me rewrite it in blue. How about this? Y equals negative 2 to the power of x minus 1. That negative sign out here in the front is going to cause it to look like this, like that. So it reflects. Instead of opening up, it opens down. So all it does, it makes it like, it's still a growth function, right? This first one, the base is 2. That means it's a growth function. Right here, the base is still 2. It's still a growth function. The only difference is now you have a negative in front, so it's growing in a negative direction. Kind of like a credit card debt, right? You could have credit cards, you don't owe any money. You start using them, you start growing in debt. You start growing in a negative direction. So that's how the a value affects the graph. If it's positive, it's opening up. If it's negative, it's opening down. But either way, the base is greater than 1, so it's growth, which means that from left to right, both of these are growing away from the asymptote. So I hope that kind of refreshes your memory on exponential growth and decay functions. And I also encourage you guys to use Desmos, right? When it comes to questions that you're still like, I don't really know what this looks like. I'm not sure if I'm sketching it right. Use Desmos, type it in, and you'll get the exact accurate graph right there. And you'll be able to see your asymptote, and you'll be able to see if it's growing up or growing in a negative direction. You'll be able to see all that. Anyhow, let me move this out of the way, and let's go back to the exponential decay functions. Sorry about that. There we go. Exponential decay functions. So a decay function has the base that's less than 1. So a pretty good function that would kind of fit this sketch is something like y equals the base being less than 1, like 1/2 to the x power. And notice that the k value, the asymptote is at the x-axis at the y value of 0. So, I mean, if I wanted to, I could put a +0 right here. I don't really have to, but if I wanted to, I could. Okay, that's a good description right there. Now, again, if I were to change the a value out here in front, there is no number out here in the front, but if I were to change it to a negative, then it'll cause this graph to reflect over the asymptote, reflect over the x-axis in this case. So if I were to rewrite or graph this one right next to it, the same identical exponential decay function, but with a negative sign instead, it would be the same exact graph, but just from over here like this. Same exact graph, it's just reflected over the x-axis. Now, either one of these, the black one or the blue one, they're both decay functions. They both have a base that's less than 1. They both have the base 1/2. So they're both decay functions. And both of them, from left to right, really do decay towards the asymptote. This red one, as you go from left to right, it's getting closer and closer and closer and closer to the asymptote. That's why it's not a growth function. From left to right, it's getting closer to the asymptote, not growing away from the asymptote. Same thing with the blue one. The only thing is that the blue one has a negative in place of the a value. So it's getting closer and closer and closer. It's decaying towards that asymptote. So I hope we're able to identify when we have a decay function, by looking at their graphs from left to right. Is it getting closer to the asymptote? It's a decay. From left to right, if it's getting further away from the asymptote, it's a growth. Also, visually, I mean, not visually, but numerically, if the base is less than 1, it's a decay function. If the base is greater than 1, it's a growth function. So let's move this to the side. I'm still going to use this actually, but I did want to bring up that there's some questions that involve me asking you to to use consecutive integer inputs. So check this out. If you're graphing by hand, obviously if you're not using Desmos, so you're graphing by hand, it's a great idea to use consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. And that might have thrown off some people, but that's what this means. If you make an input-output table, an XY table, and on the inputs you put -3, -2, -1, 0, 1, 2, 3, these consecutive numbers set it up beautifully because you could plug in your easiest input, 0, and then do the math and see what you get. So for example, let me actually use this guy right here, y equals parenthesis 1/2 to the x power. I'm going to use that function, which obviously was this red graph. It's a decay function. Let me plug in 0 right into there. Anything to the 0 power is 1, and 1 plus 0, we don't even have to worry about that 0. That will give me the output 1, okay? Now, I could plug in -3, I could plug in -2, I could plug in 1, I could plug in 2, I could plug in all these different inputs and do all that different math, or I could focus in on my decay factor of, my decay factor of 1/2 and use that decay factor of 1/2 to be able to get to my next output. 1 times 1/2 is 1/2. And then 1/2 times 1/2 is 1/4. And 1/4 times 1/2 is 1/8. And then 1/8 times 1/2 is 1/16, and so on and so on and so on. We know it's getting smaller and smaller and smaller. And it is getting smaller by half. That's why it's decaying, right? It's decaying by half. Anyway, in the other direction, if it's decaying by half, in the other direction, it's really growing by 2, if you think about the outputs. So 1/8 times 2 is 2/8, which reduces down to 1/4. 1/4 times 2 is 2/4, which reduces down to 1/2. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4, and 4 times 2 is 8. So why am I going over this problem? Because there will be questions where I say, find the corresponding outputs for the given inputs, -3, -2, -1, 0, 1, 2, 3. And the answer would be this list. This is the list of the outputs. So the answer would be 8, 4, 2, 1, 1/2, 1/4, and 1/8. Okay. Now, I did make an entire video explaining every single question on that quiz that we did so poorly on last week. I think it's posted on Tuesday's post. So if you're still struggling with exponential growth and decay, please watch that video, okay? But we also need to move on to what we're going to be covering on the second half. Well, it's not really half, it's a little bit less than half. But the second part of the test tomorrow is just going over the rules of exponents. So the way we're going to prepare for that right now is just to go over some examples. Right here we have something times something, right? Notice there's no exponent on the outside that I have to distribute, right? That rule doesn't apply. There is no exponent right there. So in reality, the parentheses are kind of pointless, right? We don't really need the parentheses. And what we need to do here is just recognize that it's all pure multiplication, right? What we really have is -2 times x to the third times y times the parentheses times 6 times x times y to the ninth. It's all pure multiplication. And we know that commutative property exists in multiplication. What does that mean? 2 times 3 is the same thing as 3 times 2. So I could switch the order, and that's exactly what I'm going to do. I'm going to get the number -2 and the number 6. -2 times 6, that'll give me -12, and that's the first part of my answer. The next part of my answer, I want to get that x to the third, and that x to the third times x, that'll give me x to the fourth. It's just rule 1 of exponents. And then last but not least, y times y to the ninth, that's y to the 10th. There's my answer, negative 12, x to the fourth, y to the 10th. You see, it's easy. Okay, so let's move on. And that was just rule 1. Rule 1, that's where when you're multiplying and you have the same base, x, simply add the exponents. 3 plus 1 is 4. Y, simply add the exponents. 1 plus 9 is 10, right? Well, a number times a number, yeah, multiply those numbers. Let's move on to one that involves something else. Fractions. You might want to jot this down. See, when I see fractions and I'm thinking rules of exponents, I'm like, oh, maybe I could cancel something out, right? If I have an x over x, I could cancel it out. Or if I have like x to the fifth over x to the fifth, I could cancel those out. But the bottom line is, when I look for that, look, there's an x up here, there's no x down here. Bummer. There's a z up here, no z. Well, there's a y, no y. Okay, so I can't cancel. So forget about that rule. You try to apply it, but there's nothing to apply it to. What other rules are there? There's negative exponents. And how do we do these? Anytime you have a negative exponent, you must grab the entire term, including the base, and you move it up to the other side. And it becomes then positive. We have another exponent up here. We're going to grab that z to the negative 4 and move it down, and that's going to become a positive z, or z to the positive 4. So how should I begin this? Let's begin this by writing what did not move. We have the 2x that did not move, and we have the y to the 8th that did not move. So when I do move up the 5 to the negative 2, it becomes 5 to the positive 2. And of course, to not get confused, put a dot right there in between the 5 squared and the 2. Okay? And also that z to the negative 4, you moved it down, it became z to the positive 4. And that's what we have so far. So the question is, could I do anything else? Now, what do I mean by could I do anything else? Maybe if this were if it were a y to the fourth, then I'd be able to add 8 plus 4 because I'd have both y's. But it's not a y, it's a z, so I cannot do anything to the denominator. That's going to stay exactly the way it is. But up on top, I could actually do 5 squared. 5 squared is 25. And then after that, I could actually do 25 times 2. 25 times 2 is 50. So let me rewrite my answer over here with a 50 instead of a 25 times 2, with an x, and on the bottom we have the y to the 8th and the z to the 4th. And that is all we could do. That is our answer. So the first one we did involved rule 1, which was if you have the same base and you're multiplying, just add the exponents. This one, I forgot what number it is. Who cares about the number of rule it is, but it's the negative exponent rule. Anytime you have a negative exponent, you have to grab it, move it to the other side, and it will become positive. Let's move on. Let's try another example. And believe me, guys, every single one of these that we go over right now, you will see them in some way or form on the test tomorrow. Number 3, ridiculously easy. You have to remember that parentheses matter, right? If you have parentheses, you include that negative sign. If you don't have parentheses, you don't include the negative sign. So right here, what's the answer? Anybody? Negative 25, right? Negative 25. What? We do the exponent first, and then you simply bring down the minus sign, right? Now, it's a totally different story if I had this. Then that would be negative 5 times negative 5, which would give us a positive 25. But notice up here, we don't have parentheses, so that's not really a negative 5 to the second power. It's 5 to the second power with a negative sign in front of the answer. Okay. So please know the difference, okay? Parentheses do matter. Parentheses make a difference. The parentheses makes that base negative as opposed to being a negative sign out in front of your answer. So please understand that. That's going to be on the test tomorrow. Another ridiculously easy one. What's the answer there, guys? That's the rule of the power of 0. Anything to the power of 0 equals 1, correct? However, right here, if you put equals 1, it's going to be wrong. What? Yeah, because the only thing that has the power of 0 is the y. The y is the only thing that has the power of 0. So what I really have is a minus 5 times 1, which is really negative 5. Okay. Now, again, it'd be a totally different story if the whole thing had a 0 on it. Then, yeah, right there, the answer would be 1. But that's not the case. We don't have parentheses. So 1 is not the answer. Probably shouldn't cross that out. 1 is not the answer. It's negative 5, because the only thing that has the power of 0 is the y, which makes that a 1. And if you have negative 5 times 1, that will give you the answer, negative 5. So we're going to have some ridiculously easy ones like that. Ridiculously easy ones like this. We do have parentheses, so that base truly is negative 1. So what is the answer there? What's negative 1 times negative 1 times negative 1 times negative 1 times negative 1? 27 times. Anybody? That's right, negative 1. Why is that? Because remember, an even power means you'll be able to group them in 2, right? If I have negative 1 to the 8th, I'll have negative 1 times negative 1 times negative 1 times negative 1. Man, okay, I probably shouldn't have done to the 8th. Let's pretend it's to the 4th, yeah? Let's do the 4th instead of the 8th. And you wrote it 4 times, and you will be able to pair them up. Oh, I could pair up these 2, and I could pair up those 2. And we know that each pair turns out to be positive, because a negative times a negative is positive. So anytime you have an even power on the base negative 1 with parentheses including that negative sign, it'll be a positive 1. But anytime it's an odd power like up here, you're going to start pairing them up, but because it's odd, you're not going to be able to pair up all of them. You're going to have 1 left over, which will take you back to the answer, negative 1. You guys with me? Again, easy questions like this will be on the test tomorrow as well. Move this out of the way. How about that guy? Ridiculously easy. What? What's the answer there? 1. That's right. Anything to the 0 power is 1. If you started canceling the z's and canceling that, like, you're just wasting your time. I mean, it's not wrong, but you're wasting your time. Why? Because at the end of it all, this whole thing is to the power of 0, which equals 1. Let's do a couple more and then we're done. Let's say I had this fraction right here. So again, I see fractions, I want to cancel things out. Is there anything I could cancel? The answer is yes. I have x squared on the bottom, that's 2x's, and I have x to the 4th up on top, that's 4x's. Both these x's, all 2 of those x's, could cancel with 2 of the 4, leaving you 2 left over. Now you might want to cancel y's, but that would be incorrect, because you really don't have a y to the 3rd down there. You have a y to the negative 3 down there. And that's the negative exponent rule. Whenever you have a negative exponent, you must grab it, move it to the other side. So this y to the negative 3, I'm going to grab it, move it up, and I'm going to write it up here as y to the positive 3. So now I'm going to put a line through it because I already moved it up and I already changed the exponent to positive. So far I've applied 2 rules. What else? I know that when I take a look at this fraction, 8 over 2, that's really 8 divided by 2, which is going to be 4, right? 8 divided by 2 is 4. 2 divided by 2 is 1. Of course, you don't need the 1 on the bottom. So let's write what we have so far. We have 4, we have x squared, and we have y to the 2nd times y to the 3rd, all over 1. There's nothing left on the bottom. So I don't really need to write over 1, but I'm showing you right now. But at the end of it all, what happens, what else could I do? I could actually multiply y to the 2nd times y to the 3rd to give me y to the 5th. add the exponents. That's rule 1. So my final answer will be 4x squared y to the 5th. Beauty. Fun stuff. What's that? You want to do more? Okay, no problem. Let's do it. Only 2 more. Number 8. I have different rules that I could apply. The easiest one is anything to the 0 power equals 1. Y to the 0 is 1. I could just scratch it out. Because, I mean, I could put a times 1 right there if I want, but it's not going to change anything. Times 1 keeps it the same. So I'm just going to scratch it out. So I either do rule 1 or the negative exponent rule. I'm going to eventually have to do both. So it doesn't matter which order you do it in, as long as you do both. So I'm going to go x to the negative 3 times x to the 7th. It's the same base. I'm going to add the exponents. So what I really have is x. What is negative 3 plus negative 7? It is negative 10. There's my answer. However, you still need to apply the negative exponent rule. You need to grab this and move it to the other side. The other side of what? If it wasn't a fraction, make it look like a fraction by putting a division bar underneath it. So what will happen, you'll have nothing left up on top, and you'll have x to the 10th on the bottom. All of these questions are coming out on tomorrow's test. Okay? Again, the majority of the test, a little more than half of the test, is on exponential growth and decay functions. Please review the quiz video that I made and posted on Tuesday. And the other half, or less than half, comes from this one, rules of exponents. Number 9, this is the last one we're doing. It's probably the most complicated one. So let's look on the inside of the parentheses and see if we could do anything. I could immediately see that 12 divided by 3 is 4. So these would cancel. I'd have a 4 left over up on top. What else? I immediately see the x to the 0. That's 1. I could just scratch that out. I immediately see the z to the 3rd up on top and the z to the 3rd on the bottom. I could cancel those out. All 3 z's cancel with all 3 z's. Now, of course, you could have done this with in a different order, but I think this is the easiest to look at the inside, cancel whatever you can. Any 0 powers, just scratch them out. And not only that, last but not least, let's take the negative exponent and move it down to the other side and make it positive. So let me see, it's already getting ridiculously messy. I want to rewrite what I have here so I don't get all confused. I have a 4 up here and nothing else. And on the bottom, I have that original y that didn't move. And I also have this yellow y that's now to the 2nd power instead of negative 2 power. And of course, I could multiply those together. So let me rewrite it one more time. I have a nice fraction in here, 4 over y to the 3rd. And I also have the power of 2 out on the outside of the parenthesis. Anytime you have a power on the outside of the parenthesis, you grab it and distribute it to all the terms on the inside as long as you don't have addition or subtraction. And we don't have addition or subtraction. So put that 2 on the 4, put the 2 on that 3, and we remember that a power to a power you multiply. So what I have here is 4 squared, which is 16, and I have y to the 3rd to the 2nd, multiply those powers, and you get y to the 6th. And ladies and gentlemen, that's your final beautiful answer for that long, complicated problem. I promise you there will be one like this. Very, very, very similar. If you understand this, you'll be good on this half of the test. Okay, so once again, more than half, maybe 60%, 55% of the test comes from exponential growth and decay functions. That's the last quiz that we kind of bombed, which I explained, and it's recorded and posted on Tuesday. Watch that video if you need that help. The second half is on rules of exponents.